All right, so this one, we're going to look at solving some equations. Get it right here. All right, so we have e to the 5 minus 3x equals 10. So these are not too complex. They can get more complex for sure. So the first step you can kind of skip on a lot of these. The first step is you want to get either the exponential part by itself or the logarithm part by itself. So in this case, this is an exponential equation. This is the exponential part. It's already by itself, so you don't really have to do that. The next step is to take the ln of both sides. So in this ln, because since this is base e, ln of both sides. And then we learned in the last video that the ln and the e will cancel each other out. And now we just have 5 minus 3x, and then put ln of 10 in the calculator and probably keep at least 4 digits. So we have 2.3026. And now it's just a simple linear equation. I mean, the numbers are not great, but it's easily doable. Subtract 5 from both sides, we get 2.6974, and then we'll divide by negative 3, and we get 0.8991. All right, so most of these, this is going to be the way it goes. Isolate the exponential part, log both sides, whichever log is most convenient, and then you have a pretty simple equation to solve. All right, so the next one, 3 to the x equals 18. Same idea. So we already have the exponential part by itself. So let's take the log of both sides, and you can do log base 3 of 3 to the x, and then log base 3 of 18. And then the log base 3 and the 3 cancel out, and x is just log base 3 of 18. So that one is not too bad. Let's talk about how to put this in the calculator, though, because a lot of the calculators will not have a different base besides base 10 when you hit the log button, or base e when you hit the ln button. So to put this one in the calculator, if you don't have the capability for doing different bases, you can have log of 18 over log of 3. So whatever the base is, just do log of that in the denominator, and then the argument that you want in the numerator. So you should get, let's see what we get here. You should get approximately 2.6309 for that. But this is the exact answer. That is the approximate answer. All right, and then the last one, we have a pretty simple word problem here. If a bacteria population starts with 100 bacteria, doubles every 3 hours, the number of bacteria after t hours is given by this function. So we have 100 times 2 to the t over 3. When will the population reach 50,000? So this is when, so we're looking for t. And so n is going to be the 50,000. And then we just need to solve for t. So in this case, the exponential part is not by itself. So we need to get that by itself first, and we're going to divide by 100. And so now we have 500 equals 2 times t over 3. And so now we can do the same thing we did in the previous problem. We'll do log base 2, base is 2, so we'll do log base 2, 500, log base 2, and now t over 3 is what we're taking the log. I'm sorry, that's not right. Log base 2 of 2 to the t over 3, and then the log base 2 and the 2 are going to cancel, and we can put this in the calculator. So let's see what we get here. 8.9658, and then the log 2 of 2 is going to cancel, and we just have t over 3. Now it's a very simple equation. Multiply both sides by 3, and we get t equals 26 point, we'll just round it 2 digits and say 26.90. All right, so again, these equations don't get too complicated here. Mostly the same steps where you want to get the exponential part by itself and then take the log of both sides, and then it's a pretty simple equation to solve. But if you have any questions, let me know.